In order to determine whether or not two functions are inverses of each other, we have an algebraic test. We'll say f and f inverse are truly inverses of each other if, when we compose them, either f composed with f inverse or f inverse composed with f, when we simplify that down, we end up with just x. If that's the case, then those two were truly inverses of each other. We can come up with a theoretical reason for why that needs to be the case by thinking about the composition in this way. Two functions are truly inverses of each other if they undo each other. So if we were to evaluate f composed with f inverse of x, this domain element is first operated on by f inverse, and f inverse is going to manipulate it or change it into something else. That output then goes into the f function, which essentially undoes everything that f inverse just did, and the result is the original x that we started with. So the algebraic test is that we're just going to compose these two functions and see if the result simplifies down to being x. Now, if f inverse is the inverse of f, then f is the inverse of f inverse, meaning that they would be inverses of each other. So it doesn't matter which direction you compose them. Either way, the output should just be x once we simplify it. So let's look at a quick example. We have two functions, and we're being asked to determine whether or not these functions are inverses of each other. Well, the algebraic test is that we need to compose the functions. If that composition simplifies down to being just x, we would say then yes, they are inverses. And as a reminder, we could compose them in either direction, and either way, they should simplify to being x. So let's begin. We'll look at the composition f composed with g, which as a reminder is f on the outside, g on the inside. So we begin by writing down our f function, which is 3x plus 2. We leave a hole for the independent variable because the g function is going to be plugged into that spot. So x minus 2 divided by 3. And now we simplify. Let's copy paste the left-hand side, which is f composed with g. And on the right, we essentially have 3 over 1 times x minus 2 over 3. And those 3's are going to cancel out to leave x minus 2, which is that product. And then we still have the plus 2 that remains over here on the end. Of course, minus 2 and plus 2 cancel each other out, and now we see that f composed with g did simplify down to being just x, which does satisfy that algebraic test, and so then we'll say, therefore, f and g are truly inverses of each other.